Welcome to our channel. Watch the video until the end. Leave a like, and subscribe to the channel to support us.
Various hypotheses have been proposed about the disappearance of the dinosaurs. The most widely accepted is that an asteroid as large as Everest hit the Earth, devastating the planet and causing a mass extinction. A simple, fascinating, and convincing explanation.
But are we really sure? In recent years, new evidence has strengthened an old theory that points the finger at another suspect 1,000 times larger and not unfamiliar to our planet.
66 million years ago, the Earth was very different. It was the last days of the Cretaceous, one of the warmest periods in the history of the Earth, and much more humid. Lush forests and jungles covered most of the planet. Even the polar regions hosted forests of ferns and prehistoric pines. Everywhere there were animals of enormous size. Pterosaurs dominated the skies. Marine lizards and long-necked monsters, up to 15 meters long, swam in the oceans. On land, all creatures larger than a meter were dinosaurs, among the most successful animals ever to appear on Earth, who dominated the world for over 150 million years and then became extinct. These majestic creatures vanished in a geological instant. It's true that during that time a large asteroid hit the Earth. But is this the real cause of the dinosaurs' death, or did it just arrive in time to take all the blame?
According to recent studies, just before the asteroid's impact, an ancestral nightmare even older than the dinosaurs decided to destroy the world.
The ancient continents looked similar to today's but with some differences. India was a gigantic tropical island, full of rainforests. But this paradise also hosted something else. The Deccan Traps, a volcanic region 1,000 kilometers wide that was dramatically coming to life. The apocalypse began quietly and silently. About 800,000 years before the impact, the Deccan Traps began emitting 10 million tons of CO2 and sulfur dioxide per year for 500,000 years, dangerously accumulating in the atmosphere. About 300,000 years before the asteroid, the Deccan Traps began to overflow with lava. Clouds of ash darkened the sky while rivers of magma incinerated vegetation-rich areas, annihilating many local ecosystems and covering the continent with dinosaur corpses. Yet, it still seems like a local catastrophe, one of many that have struck the planet over billions of years. If it had stopped, perhaps the dinosaurs would still be here. But the nightmare had not even started. The Deccan Traps did not stop spewing lava. Thus, after hundreds of thousands of years of continuous volcanic emissions, the catastrophe became global. First, the planet heated up sharply, with ocean temperatures rising by 2 degrees Celsius in just 100,000 years, a severe event, but which gave ecosystems time to adapt. But nature had a cruel joke in store. Some gases from the Deccan Traps warmed the planet while others cooled it, but the mix was unbalanced and so, after the initial warming, a cold period followed that severely tested the ecosystems that had laboriously adapted. At the same time, the sulfur in the atmosphere fell back as acid rain, while CO2 acidified the seas, killing the plankton that was, as today, at the base of the ocean food chain. For a time as long as the history of human civilization, this volcanic apocalypse triggered vast fires, earthquakes, and tsunamis that struck and shook the continent. The depths of the planet might have emitted so much heat to form hyper-hurricanes, cyclones tens of kilometers wide with winds that grazed 1,000 kilometers per hour, 3 times the deadliest hurricane ever recorded. These storms were so imposing and intense that they rose tens of kilometers into the stratosphere, piercing the ozone layer with devastating consequences for life now unprotected from solar radiation. And as if that were not enough, from the bowels of the Earth emerged huge amounts of poisonous materials. Gigantic clouds laden with mercury and hydrochloric acid covered the planet, delivering the coup de grace to the remains of a once splendid and fertile planet. With food chains broken and the world on the brink of collapse, the last dinosaurs to have walked the Earth might have died vomiting toxic foam under a deluge of acid rain. A cruel end for a noble family that had dominated the world for so long. It was the end, like a cosmic joke. In the sky, on the other side of the world, a bright dot appeared and, moments later, a 10 kilometers diameter asteroid hit the Earth with the energy of 4 billion atomic bombs.
Were the dinosaurs doomed by the Deccan Traps, or would they have survived without the asteroid?
Was it a team effort? Scientists have been hotly debating this for years. But for now, there is no definitive answer. The combination of these massive and varied natural disasters shows how the disappearance of the dinosaurs cannot be attributed to a single catastrophic event. Rather, it is a series of interconnected events that, together, created a globally inhospitable environment. New research suggests that these extended and prolonged volcanic events of the Deccan Traps may have played a crucial, if not dominant, role in the mass extinction that marked the end of the Cretaceous. The asteroid, with its devastating and immediate impact, may have simply accelerated an extinction process that was already underway, exacerbating the already critical conditions of the planet. This hypothesis raises important questions about the resilience and vulnerability of planetary ecosystems. While events like an asteroid impact are spectacular and dramatic, the cumulative effects of less visible but constant changes, such as volcanic activity, can be just as, if not more, devastating over the long term.
In light of these new findings, scientists are also reconsidering how similar events might affect life on Earth today.
Studying the extinction of the dinosaurs is not just an academic exercise to understand the past, but it also helps shape our ideas about how similar events might unfold in the future and how we might prepare for or respond to them.
Moreover, field research and the analysis of sediments and rocks continue to provide new data that may further clarify the timeline and intensity of the events that led to the end of the dinosaur era.
Science, as always, is a continually evolving process, and each new discovery adds another piece to the puzzle of this ancient mystery. In conclusion, while the debate among the scientific community continues, interest in these historical events remains high, highlighting the importance of continuing to explore, question, and understand the history of our planet. This timeline of events is based on some of the most recent reconstructions of the evolution of the Deccan Traps. I invite everyone to express their opinions in the comments and to discuss further these fascinating theories on the disappearance of the dinosaurs.